Okay, these are some problems from section 6.2, and first ones we just want to take the antiderivative. Basically, find the indefinite integral. So we're all set. Again, that's just the antiderivative. So the antiderivative of the cosine of x is the sine of x, because the derivative of the sine of x equals the cosine of x, and minus, and then here I would just use the anti-power rule. So I add 1 to 2, so I get x to the third divided by 3, and then that'd be over 3. I guess I could write this negative 3 divided by 3, and then plus c, so that just equals the sine of x plus x cubed plus c. So that's all you had to do for that. Oh, I'm sorry, this should be negative, pardon me, negative. Because there's a negative there, pardon me, just transpose that wrong. So sine of x minus x cubed plus c. Okay, the next one, same idea. I just rewrote this as a negative exponent, so it'd be a little bit easier to use the kind of power rule. So that's going to equal, and then if I add 1, that's going to be t to the third over 3 minus, and if I add 1 to this, that's going to be t to the negative 1 divided by negative 1 plus c, and that's just going to equal t to the third over 3, and a negative times a negative is positive, and that's going to be t to the negative 1, or 1 over t, whatever you'd like, and then plus c. So there's your answer there. Might be easier to box it, might be a little bit easier to see it there. There's your answer there. Okay. And then number 5. This is all set up. The antiderivative of this would be x to the 5 over 5 minus 2, and if I add 1, this is going to be x to the negative 2 divided by negative 2 plus, and then this secant, the derivative of the tangent is a secant squared, so that would just be the tangent of x plus c. So this is going to be 3 over 5, x to the 5th. That negative 2 over negative 2 is just positive 1, so that's going to be positive x to the negative 2 plus tangent of x plus c. So those are pretty easy. On number 7, okay, we just want to take the derivative of these to check. So we're saying that the antiderivative, or the integral of cosecant squared of u du equals the cotangent of u. So we just take the derivative to check that, which is what you're going to be doing in the more complicated ones, I hope, to check to make sure your answers are correct. And we have negative, and what's the derivative of the cotangent? Well, the derivative of the cotangent is negative cosecant squared of u. And the derivative of c is 0, and negative times a negative is a positive, so we just have this. Which is what we had here. So we're just trying to check that, so that checks. Okay, and number 9. Okay, the derivative, we have this. We want to show that the antiderivative of e to the 2x dx is equal to 1/2 e to the 2x plus c. So we'll just take the derivative of this and see what we get. So it's going to be 1/2, and the derivative of e to the u is e to the u du, so it's going to be e to the 2x times 2, and the derivative of c is 0, and these two cancel, so that gives me e to the 2x. So this is all they really wanted. Isn't too difficult. There you go, it's the same. And then number 11. Again, we want to show that the derivative of this is this, or the antiderivative of this is this, so we'll check this. And the derivative of the inverse tangent is, of u is just 1 over 1 plus u squared. And the derivative of c is 0, so there you go. We have that. So, nothing really too difficult there. That's all I really wanted. Okay, then number 15. I'm sorry, number 13. Verify that the integral of the func f of u with respect to u is not equal to the integral of f of u with respect to x. And this is f of u, the square root of u, or you could think of it as u to the 1/2 power. Same thing, u to the 1/2 power. And u equals x squared. So if I take the added derivative of f of u du, f of u is u to the 1/2 du, and how would we integrate that? That's just a power rule, so that would be just u, and add 1/3/2. Divided by 3/2, right, or times 2/3, I can save a step there, plus c. So that's all that is. Now, if I do the other one, over here, this would be the f of u with respect to x. First of all, everything has to be in terms of x, so f of u was the square root of u, and then I just took x and put that in there for u, so that just ends up being the square root of x squared. In other words, f of u is the square root of u, but u is x squared, so I substitute that in. But the square root of x squared is just x. And that's just going to be equal to, and then that equals x squared over 2 plus c. And you can see that these, oh, I'm sorry, I didn't go back over here. So I have to substitute in for u. In other words, u is x squared, so let me go back and do this. So that's going to equal 2/3 and what goes there is x squared, doesn't it? So let me put the x squared in there. All right, and then that's going to equal 2/3, and then x squared times the 3/2. It's just 6 over 2, which is 3, so that just ends up with x to the 3rd plus c. All right. And you can see that this and this not equal. Okay? Those are not equal. 2/3 x to the 3rd, x squared over 2, definitely not equal. So I hope that 2/3 x to the 3rd plus c and x squared over 2, or 1/2 x squared, not equal, plus c, they're not equal. Okay? So that's all they wanted you to do with number 13. Okay, and number 15.